Hello everyone, welcome back to Code with Cougar. And today I have some exciting news for you guys. I'm starting a new video series on my YouTube channel about data structures and algorithms. I know these concepts might be challenging for many of you, but trust me, they are important and they can be super interesting as well. In this series, I'll break down everything from basics of array and linked list to advanced topics like dynamic programming and graph algorithms. We will also explore topics like big O notation, sorting algorithms, and searching algorithms. I'll also provide real world examples and topics and use cases to help you understand these topics of data structures better. I'll be posting new videos frequently, so make sure to subscribe to my channel and hit the notification bell so that you guys get notified whenever a new video is dropped in my channel. And if you guys have any question or suggestion for future videos, please leave them in the comment section below, and I'll get back to your question and comments as soon as possible. So let's dive in and get started and understand what basically data structures are. In programming and computer science, data structure refers to the way we organize and store data in our application or computer memory. You can think of data structure as different containers that hold information in a certain way depending on our need. So the question would arise that why do we actually need data structure? To answer this question, let's think of when we are dealing with a large amount of data. When I say large amount of data, I'm talking about like millions of records or hundreds of thousands of records of data. It's very important to store and access the data efficiently. So data structure basically allows us to efficiently access this data, large amount of data, by providing optimized way to search the large amount of data, to sort them and manipulate these large amount of data. So think of when you guys walk to a supermarket such as Walmart. If everything is dumped on the Walmart floor in an organized way, and you are looking for a product A, it will take you a long time to search all the messy dumped items on Walmart, and it will take you a lot of time to find product A. But on the other hand, if you walk in the Walmart and see everything is well organized, everything is on their shelf, all the shelves have signs, so that it will take you less amount of time to go and find product A. Same case with data. Whenever we have a large amount of data, and if we dump it in our computer memory in an organized way, it is going to be difficult to traverse those data and search for a specific data and process those data. So data structure basically provides us a way to well organize our data in our computer memory. So basically, there are many different data types or data structures, each with its own strength and weaknesses. Some of the most common data structures include arrays, linked list, stack. We have queues, queue data structure. We have trees, and we have graphs. These are different ways of storing data in our memory. As I said, data structure is nothing but the different ways to store our data, large amount of data differently in our computer memory, so that we can efficiently access them, process them, and manipulate them. So each data structure has different purposes. For example, arrays are great for storing large amount of data in a contiguous block of memory, while accessing the data is very easy. On the other hand, linked lists are better suited for dynamic data structures that grow and shrink over time, whereas arrays does not grow or shrink. Stacks and queues, on the other hand, are useful for keeping track of order of data, while tree and graphs are better data structure for representing hierarchical or interconnected data. So learning about data structure is an important part of becoming a proficient programmer or software engineer, as it allows us to write more efficient and effective codes. In this course, we will be covering the basics of some of the most important data structures and showing you how to use them in your own programs. To summarize, all data structures are responsible for dealing with organizing the data inside our memory in different ways. So let's get ready and let's talk about each one of these data structures briefly. So in this video, I'm gonna give you a brief introduction to each one of these data structures. But in the future videos, we will be having detailed information and detailed explanation about each one of these data structures, their usages, their properties, their functionalities, and where to use them and where not to use them. So let's talk about arrays first and visualize what arrays basically mean. So let me open my this page. Suppose I want to store 5 numbers in my computer. I want to store 1, 5, 3, 2, 6. So one way to store these 5 numbers in my computer or my application is to define 5 different data types, variables of type integer. I can define int a equal to 1, int b equal to 5, int c equal to 3, and d equal to 2, and e equal to 6. So this is one way to store 5 numbers in my application. What if I have to store hundreds of numbers, or what if I want to store thousand of number or 10,000 or millions of numbers in my computer or in my application? Do I have to define thousands of variable and store them separately? No, definitely no. This is not a good practice, and it's going to be a tedious way. So we have data structures like array that allows us to store collection of elements or values under single name. So in this case, to store 5 numbers, an easy way is to define an array of size 5 and store each element in that array. So I can, when I define an array, so the program will allocate a block of size 5. Suppose I want to store say int array. To define an array, we use a square bracket in some of the programming languages like C# or Java or C++, and we will give our array a name. Let's give it my arr, or my array equal to new int of 5. So I'm going to allocate 5 memory locations to store these values. So the 5 memory cells or locations will be allocated. As we all know, array index starts from 0, goes all the way to n minus 1, where n is the size of our array. Here our size is 4 or 5, so it will go from 0 to 4, 0, 1, 2, 3, 4. So I can easily store 1 here in this cell, 5 here in this cell, and 3 here, 2 here, and 6 here. So this is one way to store a collection of values in our computer memory. As I said, arrays are type of data structures that store elements of the same type in contiguous block of memory. One important thing about arrays in most of programming languages like C#, C++, or Java is that arrays store elements of the same type. When we say int, array of int, so in this collection, we can store only integer values. We cannot store a string or other types. Also, values are stored in contiguous block of memory or one after another. So suppose this first element has an address of 100. So the second element will have an address of 104. Since in most of programming languages, integer takes 4 bytes of memory location. So if the location or the address of the first element is 100, the second element will be 104, the third element will be 108, 112, and 116. This way, all the elements in array are stored in a contiguous block of memory. So arrays are great for storing large amount of data that we want to access them quickly. So the access operation in array data structure is very quickly. We can access each element by specifying their index value. Suppose I want to access the value 6, so I can easily say my array or my ARR of the index value of 6 is 4. So I can easily access value 6 by its index value. Array data structure is good for frequently accessing data. uh, it is not a good data structure for deleting or adding values to our collection, since it is not flexible when once we define the size of array at the compile time. So the size of array will be fixed. It is not going to grow or shrink at the runtime. Once we say array of 5 integers, so the size is fixed. We cannot later on add two more numbers to our array, since we don't have space for that. So that's one of the drawbacks of array, that it has a fixed size and it's not flexible. When we want to add or delete item in an array, it's going to be costly. So by adding or insertion, we mean that the process of adding an element to an array at a specific index value or index position. So there are basically two ways to add items to an array. If we wanted to add an item to the beginning of array, for example, I want to add 10 here. So one way is to shift all the elements by one position to the right. So it's going to be a costly, since we don't have a space here. Suppose we have larger array and we have empty spaces here. So to insert a value at the beginning of array, we have to shift all the elements to the right. Same case if we wanted to insert value at the middle of the array, we have to shift all the elements to the right. So it's going to be costly. Same case with deletion. If we wanted to delete an item from the beginning of array, so we have to delete this item and shift all the elements back to the left. So that's why arrays are not good for deletion or insertion of the data. Or the second way is to create a new array which has a larger size, and we can copy this element here, this element here, and suppose we want to insert a 6 in this position, so we can insert 3 here, then we can insert 6 here, then we can insert 2 here. So creating and copying a new array, creating a new array and copying the items of the old array is going to be a costly operation. That's why the drawback for with arrays are the fixed size, and it's not suited for deletion and insertion operation. Linked list, on the other hand, allows for dynamic resizing. They are great for situations where we want to add or remove elements from our collection very frequently. So basically, what linked lists are, they are consists of nodes that are connected to each other via pointers, and each node contains a data element and a pointer to the next node. To overcome the shortcomings of arrays and have a dynamically sized data structure or collection of items, we can use linked list. As I said, linked lists are consist of nodes, and each node has a data part or and a link parts. This is a node. Here we can store our data, and the second part of a node can be linked so that it can link to another node in our computer memory. When we create a linked list, each node is created in a random location in our computer memory. Unlike arrays, they are not created in a contiguous fashion. So suppose we created a node and we wanted to store number 5 here. This may be created at address 100. When we wanted to store another value in our linked list, we simply can create another node that has a data part and a link part. So this is data part and this is link part. In data part, say we want to store 6, this node will be created at a random location in our memory. Say it has an address of 500. So to connect these two nodes and form a linked list, we can simply store the address of the newly created node to the link part of the previous node. So we can store address 5 here and link these two nodes with each other. And if we wanted to add another value to end of our linked list, we can simply create a node. Say we want to store 8. This node may have an address of 800. So we can simply store the address of this newly created node to the previous node. So we store 800, and they form a kind of link between these two nodes. As I said, this is a dynamic data structure which can grow and shrink at the runtime. We can add elements easily and remove elements from our linked list. Suppose I want to add an element or item at the beginning of my linked list here, so I can easily create a new node. Say I want to store 10 here, this might have an address of 300. So I can easily store the address of this node to my newly created node. So I want to add store 100 here, so that there's a link between the this node and our newly created node. So this node is becoming the first node or the first item in our linked list now. So we could easily insert a value at the beginning of my linked list. Unlike arrays, we don't have to worry about shifting the elements to the right when we want to insert at the beginning. Same case at the middle. If we want to add an item or a node at the middle of the linked list, we can create a new node. Say I want to store 15. This new node may have an address of say 1500. So what I can easily do is instead of 500, I can store the value 1500 here. So this link is going to be broken. And since I stored 15 here, a link will be created between these two nodes. To link these two nodes, I can store value 500 here, and our linked list is formed. So this way we can easily insert values at the middle of the linked list. Same case as with deletion. Suppose I want to delete this newly added node back from my linked list. What can I do is simply store the value of this node to this node. So I can store 500 here. A link will be created. So since I deleted the others, this link will be broken and this link will be broken. So we can easily delete this link. So this way, linked list is a good data structure for situations where removal of data and insertion of that data is very frequent. But traversal or search of data is not good for in the case of a linked list, since for searching data we have to start from the beginning node and go all the way until we find the specific node. So linked lists are not good for searching or traversal of data. Same case, we have a stack and queue data structure. These data structures are used to keep track of the order of data or elements that are added and removed. For a stack is a LIFO data structure or last in first out data structure. So in case of a stack, think of a stack like a box where we can insert or put elements from only one end of the box. So we can insert elements from here and we can pop or remove elements from the same end of the stack. So these are LIFO data structure, means last in first out data structure. The item inserted last will be the item inserted first. Suppose I want to insert 1, 5, and 6 in my stack. So I'm going to insert 1, then I will insert 5, then I will insert 6 here. So the last item inserted will be the first item removed from the stack, since we can only insert from the one end of stack and also can only remove from one end. To remove an item from a stack, so we will first remove 6, then 5, then 1. Then we have queue, on the other hand, or the first in first out data structure, meaning that the first element added to the queue will be the first element removed or popped from the queue. Queue or FIFO data structure or first in first out data structure. Suppose this is my queue and I want to add 1, 5, and 6. So first I'm going to add 1. Remember that in the queue we can add from one end of the data structure and remove from other end. So I can add 1 here. I can add from this end only I can add 5, then I can add 6. So to remove an element from queue, we can remove from this side. First we have to remove 1, then we have to remove 5, then we have to remove 6. So that's why FIFO is first in, first out. We first end or inserted one, and whenever we wanted to remove an element, so one will be the first item to be removed from a stack. Same case, we have trees that are hierarchical data structure that consist of nodes connected to each other via edges. So if we have a tree, this is one node which consists of data. This node might have another child nodes that are connected via these edges to each other. This node might have another two nodes. Uh, this node may have one node. So this is a data structure to represent data of hierarchical nature. Trees are often useful for scenarios where our data has a hierarchical nature or fashion. Graphs, on the other hand, are data structures that represent a collection of nodes and edges that connect these nodes. So graphs are basically useful for representing relationships between elements that may not be hierarchical in nature, such as social networks or transportation network. So in case of graph, we also have nodes, and these nodes are connected to each other via edges. Each node and graph are also called vertices. So this is a simple graph we have. So the choice of data structures, we saw different data structures briefly. The choice of each data structure depends on a specific application and type of operation that we will be performing on the data. For example, if we perform accessing data very frequently, so data array might be a good choice for storing our data. But in a scenario where we want to insert or delete data very frequently, so in that case, array might not be a good choice. We can use linked list instead. So also efficient algorithms can be developed for different data structures, which can greatly improve the performance of the programs that use them. So many people, especially people who are new to the world of programming, assume that data structures are programming languages like C, C++, or Java. But literally, that's not true. Data structures are not programming languages, but rather a set of algorithms that we can use them in any programming languages to structure our data in our computer memory. So think of data structure as a blueprint or plan for organizing and managing data efficiently, which is especially important when dealing with large amount of data. So data structures are, as I said, they are language agnostic. Each programming language may have its own syntax and a specific way of working with data structures, but the core concept and algorithm remains the same. So remember, data structures are not programming languages, but rather a set of algorithms that allows us to structure and manage data in efficient manner, regardless of the programming languages we are using. So this is a good representation of classification of data structures. We have broadly data structures are classified into linear data structures and nonlinear data structures. So basically, by linear data structure, we mean the data structures that the elements are arranged in a linear fashion or sequential order. This means that each element is connected to its previous element and its next element, forming a linear chain of data. Example of linear data structures include arrays, linked list, queue, stack, etc. So in the case of array, we saw each element was after each other, and in case of linked list, we saw that each element was linked using a pointer. On the other hand, nonlinear data structures do not follow a linear or sequential order. This data structure can have multiple branches, and each element can have multiple connection to other elements. Example of non-linear data structure, we saw tree having multiple branches and multiple nodes can be connected to one branch. Also, graph also type of nonlinear data structure. So in summary, Linear data structures are those where data elements are arranged in a sequential or linear order, while nonlinear data structure are those where elements can have multiple connections and they do not follow a linear order. So understanding the difference between these two types of data structure is important for choosing the appropriate data structure for different tasks in programming. So these are the also we have static and dynamic data structures. Uh, so static data structures basically is a type of data structures where the size allocated to the data structure at the compile time. Therefore, the maximum size is fixed, like arrays. At the compile time, we define the size of the array. Once we define that, we cannot shrink or increase the size of the array. We also have dynamic data structures like linked list. These are type of data structures where the size allocated at the runtime. Therefore, maximizing and minimizing the size of these data structures are flexible, like linked list. We can add as many items to the linked list at the runtime as we want, and also we can remove them, remove as many elements as we want from the linked list data structure. Now let's talk about the major operations that we can perform on different data structures. So these operations are fundamental to working with data structures regardless of the type or the type of data structure we are using. So the first operation we are going to talk about is accessing an element from a data structure. So this operation basically involves retrieving a specific element from data structure, such as by using index or by using a key value. For example, accessing element in an array by using index value, or accessing an element from a dictionary. We can access the element from a dictionary by its key value. So the second operation is inserting an element to data structure or to collection of data. So this operation basically involves adding elements to the data structure. For example, we can insert new node to a linked list. We saw that how to insert a new node to the beginning, end, or the middle of the linked list. The third operation is deleting an element from a collection of elements. So this is basically removing an element from the data structure. For example, deleting a node from a binary tree, or deleting a node from a linked list. Next, we have searching operation so that we can traverse through the elements in a data structure and search for a specific element. We have then sorting operation. This operation involves arranging or rearranging the elements of a data structure in a specific order, such as alphabetical or numerical order. For example, sorting an array in ascending or descending order. Then we have a traversing operation. This operation involves visiting each element of the data structure either sequentially or using specific algorithms. For example, traversing a tree using a depth first search algorithm, or traversing the elements of an array in a linear fashion. Then we have a merging operation that we can perform on data structures. So this operation basically is combining two or more data structure into a single data structure. Then we can also split two data structures. So this is dividing a data structure into smaller sub sections or subparts. So now let's talk about advantages of data structures. Data structures are essential part of computer science and programming, and understanding their advantages can help us write better code and better softwares. So the first advantages of data structures are efficient data access. So as we mentioned, data structures provide an optimized way to store and retrieve data, which can significantly improve the speed of our data access and also speed of our application. For example, using an index to access element in an array is much faster than searching for elements in an unsorted list. As we mentioned, arrays data structure are best for accessing data, whereas they're not good for insertion and deletion. But on the other hand, linked list is a better choice for deletion and insertion, but a linked list is not good for accessing data frequently. So the second advantages of data structure is efficient memory utilization, as they provide efficient way to allocate and deallocate memory, which can reduce memory wastage and improve programming performance. For example, we saw that linked list allows for dynamic memory allocation, making them more memory efficient than arrays. We saw that arrays are fixed size. Once we allocate the amount of memory to the array data structure, so that amount is fixed, it cannot grow or shrink at the runtime. So suppose we allocate an integer array of thousands, so we only store 100 integers in our array. So the rest of the 900 block of memory that are allocated will be wasted, and we no longer use that. But it is not the case with the linked list. With the linked list, we dynamically grew the size of our linked list and almost shrink the size of the linked list as we delete the items or elements from our linked list. So the third advantages of data structures is better algorithm efficiency, as data structures provide optimized algorithm for common operations like searching and sorting, which can significantly improve algorithm efficiency of operations on data structures. The fourth advantages of data structure is encapsulation of data. So as data structures allows us to encapsulate data and operation on data into a single entity. For example, we can use a class to represent a data structure like a stack or queue, and we can encapsulate the data and operation on that stack and queue under a single entity called class. So the fifth advantages of data structure is better organization and maintenance, as they allows us to organize and maintain our data more efficiently, which can reduce program complexity and improve maintainability. For example, using a tree, we can represent hierarchical data and make program more organized and easier to maintain. So these advantages of data structure make them an essential tool in computer science and software engineering. They provide efficient data access, memory utilization, efficient algorithms, encapsulation of data, and better organization and maintenance. So by understanding these advantages, we can create better programs and better softwares and improve our overall program skills of us and improve our overall programming skills. So this was a quick video about introduction to data structures. Hope you guys liked it, and please don't forget to subscribe to Code with Cougar, and see you in the next video. Bye bye.